Hi, welcome back. My name is Dennis. This is Foundations Python using decision controls. Let's go ahead and get started. Our learning objectives today include creating sample programs to evaluate if-then-else decisions, so branching. We want to be able to iterate actions using loops over different data sets, and we want to apply binary choices to data types and the condition evaluations that go with it. This is actually the core logic of many applications. So branching and error handling is our first section. Branching, when we mean branching, we mean really decisions going somewhere based on A or B, and how to handle those errors gracefully to make sure that you just don't crash anytime there's a misconfiguration or invalid input, for instance. So branching includes multiple factors. Like I said, it sounds exactly how it means, branching. It's going to one branch or another, depending on your requirements. So let's use our trusty pin here. If I can get this working, there we go. I don't know why this always does this. How many branches did you see here? Pause the video and think about it before we continue. All right, did you get that? So branching, we have one branch here. We have another branch here. We have three possible choices of items here. We have our first decision tree right here, point A and point B. Is X less than Y? If yes, then go over here, which is choice one. If no, is X greater than Y? And you have two choices again here, and just choices 2 and 3 based on your conditions. This is known as an if-else, and really these could be if-else and multiple if-else statements nested together. In this case, we have a nested one, which is right here, which is the initial if, and then we have an else if, which is also called elif. How does it look like in code? Well, let's take a look at it. We'll take user input from standard in. We'll also assign a B variable, and we'll make a comparison, a very simple comparison. If A equals 10, right? If our user input is 10, then it really is 10. Else if A is not equal to 10, create a range using the input. So we'll say A is now part of the upper bound of the range, remember -1, and then loop, this is the number within the range accordingly. We'll stop there for a second. Enter 4. So if I entered 4, yeah, 1, 2, and 3 make a lot of sense. Elif A is less than 5, will this condition execute? And the answer is we didn't see it. No, right? We didn't print the range again. Why? Well, because even though it meets the criteria of less than 5, it's because it went down a list and we had false, and then we had true, and then it went into this loop instead. And because it went over here in true, it doesn't need to run this now. And that's something to really keep in mind as you go through your programming efforts. Know that the first true match is where it actually branches and goes into the decision tree right here. What about if we use multiple ifs? That sounds pretty cool. So instead of saying elif, let's just have multiple ifs. Saying if we meet the condition, wait for it. Let's try it again. Enter 4. Yep, it's 1 through 4 this time. Notice that we use a +1. And now, if A is less than 5, also print me the length, which is now 4. A much better condition will return. So now, if you need to match multiple conditions based on one input, multiple if statements make a lot more sense than elifs. How about try and catch, right? Try except and finalize. So try catch is PowerShell, try except is Python. This allows you to have an attempt at functional logic before it errors out, and then you can actually catch it and try to do an exception and do something else with it just in case. You also have a finally, which is to catch all for everything that is part of an exception that you can't handle and don't know how to handle. Let's start off with inputs. Standard input again. A is an integer, right? We'll make A an integer instead of a string. And enter a number multiple by 5, which is usually 5. Result times 5, print the result, and using a default number. What happened here? Well, why did we have an output like that? Because we entered string. We actually didn't enter a number. So we never got to here. And it's just saying except use a default number. Don't crash, just use a default. And so A is now equal to 1, and the result is 5. So instead of crashing out, we still executed something. And of course, finally, execute this code regardless of the error, right? So you can actually X out finally if you didn't want to see that too. So excepts are a great place to try in case there's an error. Don't crash the entire program, continue running. So graceful error handling. And that's when you want to use a try except. All right, iterations. So when you think iterations, think about looping, fors, do whiles. We've seen this before, not this exact example, but things like it. I have a list, right? Something that can be iterated against, or an array, or anything else. And then for I in my list, print the type and what the item is, which is what we see right here. Now, let's create another list, and we have a counter. Right? Remember my song of does this repeat? For each element in my number list, do something with the counter. Add the counter up, and then use something with that counter and additional multiplications of 10, which is right here. How about string? Are strings iterable other than lists? Why, certainly. Remember we used characters and did substring circuits? Just do a for loop on that. Set the counter, and then for anything in my string, space equals space, and say if foo equals a space, count the spaces, count the number of spaces in my string, which should be grand total of 3. 1, 2, 3. We see that right here. How about something else? Dictionaries. That's a great way to iterate over them, right? We saw this before, and we kind of didn't have a good understanding, but now we understand, most importantly, that our for loop, right, it has the same exact format, only when you're using dictionary, use items and specify your key and value iterables. And you can actually print them out right here based on key 1, value 1, key 2, value 2. What does all this have in common? Well, look close. We have the for keyword. Whoops. We have our indentation of what we want to do with that iteration. And we always have the colon. So the syntax is for something to iterate in the iteration object that you want to target, colon, do something with it, right, at the second line. Now, why would you want to use a for loop again? When you know there's a finite set, right? When you know what the length of the object is. Go ahead and use a for loop and iterate when there's a finite set. In tandem, you can also use while loops. While loops are great if you don't know when the condition is going to change. So if the condition changes, then stop the loop. Escape the loop. So instead of a counter going upwards, we have a counter upwards based on independent requirements. We have a counter that says stop the loop after the counter has reached something. Now, here's what's going wrong. Counter equals 0, and while counter is less than 5, loop my life away. So basically exit the loop after 5 ones, right? 5 will not be less than 5 pretty soon, empty the loop 5 times. What about this? Result equals 0. And while the result is not 25, enter, right? 5 times 10 equals something, Right? What's your input? 25. If it's not 25, print wrong. If it is 25, print right. So basically, keep on asking the question until you get it right, which is what? Potentially an infinite loop if you didn't have an escape condition, right? So if you don't have an escape condition, which is this, you might be in for an infinite loop. Be careful with while loops. Make sure you always include an exit condition. All right, it's time for a break. Then we'll do a demo when you come back. All right, welcome back. I hope you had a great break. Let's go over the iterations one last time. For loops are great for when you have finite objects. So my string, we can iterate over that. This is a sentence. And then we'll use for I or X, doesn't matter really, or for character, as long as it's not a keyword. So for I in my string, colon, indentation, print I, and we'll run our mini program here, right? Including the spaces. I can also do something else besides print I. I can go ahead and print I without any spaces, or I can add it into a nice multi-value list. So we'll say my list equals an empty list. Right? You have to put this outside the loop. Now take my list and add append I. How many elements do you think I'll have after this? Okay, I printed it out. My list is in memory. Oh, that's a lot of elements. Let's take a length of my list. 18 characters total, including the spaces, right? And if I wanted to figure out which element I wanted, such as the I, right? Well, my list, and then we'll say element number 0, 1, 2, the first iteration, we'll say 2. And I get the I returned back. Pretty straightforward. How about a do while? Well, here's the dangerous item. We'll keep my string. And if we take the length, so length of string equals length my string, and we'll say, and what is that? So we'll say that's 18, right? So length of string 18, and I misspelled that. So length. So 18, and we're going to say while length of string less than 20, do print my string. Now, what will happen? Pause the video, think about it before we continue. Okay, did you have some time to think about it? This is going to create an infinite loop because length of my string will always be 18, and I'm not creating a escape condition. So when using a while loop, always make sure you have an escape condition, even if you have to test it out. So what we can say is length of my string. So while less than 25, for instance, we'll just bump it a little bit, equals length of my string plus 1, right? Now it only ran a finite amount of times, and I'm stopping a dangerous condition. I'm creating an escape routine. Let's do one more example. Let's do a fun one. How about some sample code? I'm going to import the random library. My string is foo_bar for you. I'm going to iterate it. And I didn't indent. So I need to indent this. And let's see if that works here. Nope, because I need to indent this too. There we go. So what am I doing here? I'm saying using the random module, here's my string. For each character in my string, take the length. And then for random range, take the ceiling of it, right? Take the ceiling or range and take the random range anywhere from the 0 to the ceiling of it, and then print the index of a random portion. So notice here that I'm printing not foobar for you, I'm printing a random character from my string indexes. Okay, then it makes sense to you. Follow along first, right? Understand what the for loop is doing. Take your take your length value, and just go ahead and do these in your interaction Python by itself and see what happens using it. And don't forget to read the documentation, right? Random, okay? That rand range is a method. Then go ahead and print that. All right, that's it for now. We'll see you in the next lecture. Thanks for watching.